Okay, so now we want to talk about the entity relationship model. As I just said, it's about modeling information before we actually implement a database. So the idea, why it's a good idea, we just talked about that, and why we need models at all. Now we want to look at the specific type of model and a specific notation for modeling information. And we start by looking at a example of an entity relationship model, and this one is a not too complex example which gives us all the different notations that we need to understand, and we want to try to get an understanding of what's modeled here and also look at the different notation elements. So that's basically an information model about, and you can already see by the names of the boxes. So we have supplier, raw material, product, and warehouse as they are labeled. And then we have these small routes. I don't know if they actually call that, so Routen, which also have names, supplied by, part of, or stocked in. And then we have these ellipses, which also contain a label, and these what these do we'll learn in a second. So this is basically one model, and you can try to understand it. Maybe it's even intuitive, I don't know, but we will look at what each of these parts means in a second. So does anyone have an intuitive understanding of what these parts or these notation elements could mean? Yes?
Well, we have a supplier that has like an ID number, an ID, and the supplier has a name, so it could be ID and legal, and they have an address. And we as a producing company get our raw material by these suppliers. And these raw materials also have an ID and are called like eggs and milk and so on. And then we have the products that we make by using this raw material. So we can make cake using yes, the milk and the eggs and so on. And then when we have produced these products, we can stock them in the warehouse. And then we have, I don't know, shelf number 1 and 2 and 3 for chocolate cakes and caramel cakes. And yes, so it seems that we have a lot of raw materials, and we always get the one raw material from one supplier. So I think it's the 1 to n. So we buy the eggs only from Aldi and not from Lidl.
Okay, yeah.
And then we had a lot of products, and in these products there are lots of raw materials. So we have the chocolate cake and the caramel cake and the strawberry cake. And in all of these products we have different raw material. And then the product in the warehouse is linked, well, the product is always in the same shelf, for example.
Or the same warehouse, yeah. Yeah, so we don't need to go any further. You already intuitively understand the model, so we can skip to the next point then. So, but perfectly described. That's very precisely what the model is trying to express. So you identified all the different entities, as they are called, so the green boxes, and then you have the routes, which are called relationships. And you described it, so it's supplier and raw material. So a raw material is supplied by a supplier, and if you read that from top to bottom, it's basically how you would read that. So raw material is supplied by supplier, raw material is part of a product, and the product is stocked in a warehouse. The only thing that you got wrong is that we do not have a model, or in this model there's no notion of a shelf, but you said it's going to be in one shelf. That would be missing, so that would be a good point. If you discussed about it and you said, okay, we need to model exactly on which shelf a product is, that model would not be sufficient.
I thought that the warehouse would be, but okay, yes.
Yeah, so the warehouse currently in this model has only a number, name, and a size, so there's no way how we could model that we put it in a particular shelf. But we already were way too far, so we're going to go through it step by step. But it seems like, I don't know how the rest of you understood it, but it seems like it's quite intuitive, and that's the the idea, of course, of this kind of model is that people understand it or can understand it with little knowledge or little previous knowledge. So if you explain to someone what these different symbols mean, they should be able to understand what's being modeled here. Of course, there's a little bit more to it when you think about how you can implement that later in a database. You always, so if you know that, you always have this in mind, and you think a little bit differently about it, but only knowing these symbols is basically sufficient to model a large part of information requirements that we have here. So okay, let's anyway go through the different parts. So first of all, what is the entity relationship model? It's a notation. So we have the entity relationship model and the notation. So the notation we use to create this kind of model, and it describes information objects and their relationships in a formal notation. And as I said, the formal part is important because that gives us, or that eliminates the room for misinterpretation. So when I describe to you, so we have warehouses and parts and raw materials and stuff like that, and you go to someone else and tell them what I told you, there might be the effect that you're losing or misinterpreting information, and the third person then has again a different interpretation, and we come up with a different result at the end. But having a formal description where we know exactly what each of these symbols means, this is not an issue anymore, and we can very precisely describe what we want in our information model. So, and it describes information objects and their relationships, and information objects is what we call an entity or an entity type in the entity relationship model. Entity types are basically the abstract class of information objects, and an entity is a particular instantiation of that. So let me give you an example. For raw materials, the entity type is raw material. It's the class where many raw material entities belong to. So for example, a raw material like hops for our beer is one instantiation of the entity type raw material. Okay, so basically hops is the entity and the entity type is raw material. We will use these terms interchangeably a little bit. So when we talk about the model, it's actually entity type, but I will use the word entity a lot. And formally correct would be entity type. So if you read about it in textbook, the distinction might be made. So basically what we need to know is it's an object from the real world. Well, it can be, of course, a fictional world, but usually we model the real world. So we have something in the real world that we want to map to our information system, and basically that's the square, and the color doesn't matter. You can choose whatever color you want. I just chose those colors so we can distinguish them better, and then you put in a name for the entity type into the square, or yeah, and then you can describe your entity type with different attributes. So an attribute you can think of like columns in a spreadsheet. So you, for your spreadsheet that you created, you had the date when the sales transaction happened. You had maybe the number of bottles and stuff like that. That would all be attributes in our information model. And here, for the raw material, we have, as you correctly stated, we have a number that identifies the raw material. We have a name, and we have a unit. We could have much more attributes along. This is just for simplification. So we would put every attribute in here that we want to model for a raw material. And these attributes describe the object. And then the third and almost last notation element that we need to understand is the relationship. And the relationship is this route. And it's, again, the color doesn't matter. I chose this color to distinguish them better. And this is a logical association between entities or a relationship. So if two entities or objects from the real world have some relation, and usually they do, so in an information model, all of our entities should be somehow related. Otherwise, they would not make, or they wouldn't be part of the model. So we usually model things that have some context or are somehow related. So this can be across many steps. So for example, the supplier has no direct relationship with our warehouse, but it does have an indirect relation via the raw material and the products and then to the warehouse. So if we had an entity that has no connection to anything else, we would have to question whether that's correct. Can happen, but usually they are interconnected. Okay, so and then we give that relationship a name, and it should always be a speaking name. So we should always choose a name that expresses to someone else who reads it immediately what the relationship is. And there is, of course, some room for misunderstanding. So because anytime we use our language, English or German, we have some room for interpretation, and it should be as precise as possible. So as a speaking name as possible. So raw material supplied by, we could also read it the other way around. Supplier supplies raw material, so we could also have written supplies. It depends on which way you read it, and there's no formal, so there's no rule how you should read them. It's basically just, if you read it the other way around, it's often just you change from passive voice to active voice. Sometimes it doesn't make any sense to read it the other way around, but people who read it will get it immediately. So it usually makes sense just in one direction. And then we have the last thing, which is not a notation element itself, but it's an additional information that we can put in, and we should put in. It's crucial and important. Is the so-called cardinality. And you already gave a precise explanation of what it does. So we can specify for a relationship how many of entity A are in a relationship with how many of entity B. So this example here says, if we read from here, we say one supplier supplies n raw materials, and n is simply the notion for any number. So 1 or 2 or 3 or 1,000 or 1,000,000, or 0 also. So a supplier can supply more than one raw material, any number basically. And the other way around, we can say n raw materials are supplied by exactly one supplier. And that means we do not have our hops from 2 different suppliers, we only have it from one or the other. So that's basically how we model it here. If we wanted to say, well, we could also have 2 different suppliers for our hops, then we need to change the 1 into an M, which makes it an N to M relationship, and that means any number of suppliers can supply our raw material, and the other way around, any number of suppliers can supply as many materials as they want. So this is crucial because this gives us a hint of how we need to implement it in a database later on. So how many of A are in a relationship with B. There's, for completeness, there's also a one-to-one relationship, which we hardly find in practice, but it exists. So that would mean one entity and another one have exactly one pair and match. So for example, if I modeled person and passport as 2 different entities, one person has exactly one passport, and one passport is associated with exactly one person. So there's no more other entities involved in this relationship. So it's a 1-1 relationship. All right, cardinality. This is an image with an example of the different types of cardinalities that can exist. So I just talked about the 1-to-1 relationship. It's very rare, I would say, because we usually intuitively model it as being one entity. So if we have passport and person, we are tempted to model this as person having a passport number or something like that. So all the attributes from the passport are then an attribute of the person. We could model it as 2 different entity types if we wanted to, and if it's necessary, we could do that. So that's the one on the upper left corner. And then we have 1 to n and n to 1, which is basically the same thing, but the other way around, right? So 1 to n means every entity type of A can be in a relationship with one or more entities of type B. And here's a visual representation of that. So if I have entity type A, and these are entities, A is the entity type, then an entity type of A, so one entity type entity of A can have n associations in entity type B. So this one can have 2, and this one has also 2, or it can have none, like this one. The other way around, this is actually wrong. So this is a violation. I just noticed. So you cannot have B, which has 2 associations in A, because any number of B can only have 1 number in A. So this is wrong. I need to change that. And then the other way around, you just exchange n and 1. So it's now every entity type of B can be in relationship with one or more entities of type A. And I hope this is correct. So B has can have a relationship with more than one entity of type A. That's correct, and that's correct. And the other way around, any entity belonging to entity type A can have only one association with an entity in entity type B, and that's also correct. So this one has only one, this one has only one, this one has only one, and this one has only one. As I said, this one is incorrect because it has actually 2. I need to change that. So this is cardinality, and with that we can understand fully this model, and the whole idea of modeling the information, as we'll see later, is, as I said, discussion about it. So once we have a formal description, it's much easier to talk about it, and it's also much easier to implement it later on in a solution such as a database. So there are even formal rules for how to transform such an entity relationship model into a relational database, which we can apply, and it's quite simple. So once you have that, it's a smaller step to implementing the database. You make less mistakes because you have already taken care that the requirements regarding the information is already modeled in this model.